We turn now to that rare tsunami advisory for the entire North American West Coast from Alaska to California.
Details are emerging of the powerful impact of the volcanic eruption that has triggered tsunami warnings across the Pacific Ocean.
In our world, oceans are home to many wonders and mysteries, but they also harbor some of the most destructive forces of nature. Tsunamis are one of these forces. Throughout history, tsunamis have caused devastation and death in many parts of the world, but none of them compare to the one that is about to happen. A colossal tsunami is brewing, and this time its sights are set on European cities. How likely is this devastating event? What would be the impact of such a cataclysmic event? And is there anything we can do to prevent or survive it? Join us as we investigate details about the deadliest tsunami of all time that is about to happen. UNESCO, the United Nations Educational, Scientific, and Cultural Organization, is a global leader in promoting and protecting the world's cultural heritage and scientific endeavors. But recently, this esteemed organization issued a dire warning that sent shockwaves across Europe. A massive tsunami is looming over the Mediterranean coast, threatening to wipe out some of the continent's most iconic cities. Marseille in France, Istanbul in Turkey, and Alexandria in Egypt are among the potential targets of this impending disaster. What makes this warning so alarming is the certainty with which UNESCO's scientists have delivered it. They claim that their calculations are irrefutable. A colossal wave is inevitable, and it could strike at any moment. But what exactly could be the cause of the inevitable tsunami that is looming over Europe? We'll explore this in more detail later in this video. But first, let's take a look at how tsunamis are formed and why they are so dangerous. Tsunamis are giant waves that are triggered by underwater disturbances such as earthquakes, volcanic eruptions, landslides, or meteor impacts. When these events displace a large volume of water, they create a series of waves that travel across the ocean at high speeds. As the waves approach the shore, they slow down and increase in height, sometimes reaching tens of meters. The force and volume of water can then inundate coastal areas, causing massive damage and loss of life. The United Nations, sharing UNESCO's concern, has estimated that by next year, the tsunami risk will expand to 40 more cities in 21 different countries. This means that millions of people living in coastal areas could face the wrath of the ocean's fury. While these organizations strive to provide accurate and timely information, there's one unsettling detail that adds to the uncertainty of this looming threat. Predicting the exact height of the tsunami is currently beyond our capabilities. However, experts speculate that if the waves reach a minimum height of 1.5 meters, the damage will be catastrophic. We are talking about waves that can sweep away cars, cut off electricity, and inundate the lower floors of buildings, causing widespread chaos and destruction. As terrifying as the tsunami scenario is, it's not the only danger hiding under the sea. Tsunamis are not a new phenomenon. They have been documented and studied for centuries thanks to historical records and geological evidence. By examining the traces of ancient tsunamis, scientists can learn about their causes and sometimes even forecast their recurrence. One of the most striking examples is the Chicxulub crater, a huge dent on Earth's surface created by an asteroid impact 66 million years ago. This cataclysmic event unleashed a 100-meter-high tsunami that would tower over the Eiffel Tower if it were to happen today. The ensuing devastation wiped out most of the life on the planet, showing how vulnerable we are to such colossal natural forces. But Europe's imminent tsunami is not the only threat we face. There are other hidden dangers lurking in the depths of the ocean, waiting to unleash their power. One such phenomenon is the solitary killer wave. These rogue waves can reach heights of more than 30 meters, which is 15 times the size of an average wave. The USS Ramapo, a ship that gained notoriety for surviving a 34-meter-high wave, showcased the destructive potential of such solitary giants. Most vessels confronting such waves are not as fortunate and are often swiftly claimed by the relentless ocean. But what causes these rogue waves to form? Scientists have proposed various theories to explain the origin of these waves, such as constructive interference, nonlinear effects, wind and current interactions, and instability mechanisms. However, None of these theories can fully account for the complexity and unpredictability of these waves. Moreover, detecting them is a challenge, as they often appear without warning and disappear quickly. Square waves, another little-known oceanic hazard, present yet another danger. These waves intersect at right angles, creating a checkerboard-like pattern on the water's surface. Such conditions arise when wind and sea currents push waves in opposite directions. And although square waves typically don't exceed 3 meters in height, they can still envelop ships in a vice-like grip from all sides, leading to near-certain doom. Square waves are rare, but they have been observed in some locations, such as the Isle of Ré in France and the Cape of Good Hope in South Africa. These waves are dangerous because they create strong rip currents and powerful undertows that can drag ships and swimmers underwater. The rarest of these oceanic phenomena is the drone wave, which still eludes comprehensive study due to its extreme infrequency. In 1995, one such wave was detected in the North Sea, reaching a staggering height of 27 meters. However, this single recorded instance doesn't necessarily imply that drone waves are rare by nature. These killers could potentially emerge more frequently, but their devastating force means that eyewitness accounts are seldom available to recount their appearances. Drone waves are long and solitary waves that travel at high speeds across the ocean without losing much energy or shape. They are believed to be caused by the resonance between the natural frequency of the ocean and the frequency of the wind. However, this theory is not fully proven, and there may be other factors involved. Preventing them is impossible, as they are beyond our control. These are just some of the hidden dangers that lurk in the depths of the ocean, waiting to unleash their power. But there are many more mysteries and secrets that the ocean holds, and some of them could pose a threat to our safety and security. However, the tsunami is still one of the most common and deadly threats. Tsunamis can strike any coast, but some regions are more prone to them than others. One of these regions is the South American Atacama Desert, where archaeologists have stumbled upon peculiar artifacts. Sea stones, pebbles, and shells were discovered embedded in sedimentary rocks located kilometers away from the ocean. Moreover, the remnants of stone buildings found in the vicinity show signs of displacement, as if some tremendous force had tilted or pushed them. Upon closer examination, scientists were able to piece together the harrowing events that unfolded nearly 4,000 years ago. A mega-earthquake had shaken the modern Chilean territory, causing a tsunami with waves soaring as high as 20 meters. This wave could have easily swallowed the Chilean monumental lighthouse of La Serena I, which stood as a mute witness to the devastating power of these natural forces. The underlying cause of this recurrent danger in Chile is the collision of two massive tectonic plates, the Nazca Oceanic Plate and the South American Continental Plate. As the former slowly descends beneath the latter, earthquakes and tsunamis become recurring phenomena in the region. Notably, in 1960, the world bore witness to the most potent earthquake in human history, which rocked Chile with a magnitude of 9.5. This cataclysm was followed by a tsunami, and though the recorded wave height stood at a mere 10 meters, it was still enough to decimate numerous coastal towns, claiming the lives of 150 people. As the tsunami reached the shores of California, the death toll surged to a staggering 6,000 lives lost. The recurring pattern of these tsunamis in Chile suggests that such a catastrophic event takes place approximately every 3,500 years. Modern tsunamis, it seems, are in no way inferior to their prehistoric counterparts in terms of destructive potential. In fact, they are even more dangerous due to the increased population density and infrastructure development along the coastlines. These factors make the coastal regions more vulnerable to the devastating effects of the giant waves that can be triggered by various natural phenomena, such as earthquakes, landslides, or volcanic eruptions. One of the most recent examples of such a disaster occurred on the 28th of September 2023, when a powerful 7.4 magnitude earthquake off the coast of Indonesia triggered a tsunami, affecting around 1.5 million people on the island of Sulawesi. The earthquake was followed by a series of aftershocks, some of which were also strong enough to generate tsunamis. The waves reached heights of up to 6 meters and swept away buildings, cars, and people along the shorelines of Palu Bay and Donggala. While the full extent of the damage is still emerging, more than 2,000 people have died and about 212,000 displaced. At least 1,200 schools from early childhood to secondary schools have been affected, impacting 184,094 students and 12,988 teachers. Many of the survivors are in urgent need of food, water, shelter, and medical care. The humanitarian response has been hampered by the lack of access to affected areas, the breakdown of communication networks, and the security risks posed by looting and violence. In Palu, the most affected city, more than half of the population was displaced. Telecommunication remains an issue, and access to affected areas has been challenging due to rubble. Communities in more remote areas have been cut off by broken roads, landslides, and crippled communications as aid begins to trickle through. The Indonesian government has declared a state of emergency and has requested international assistance. Several countries and organizations have pledged to provide financial and logistical support, as well as personnel and equipment for search and rescue operations. The tsunami that hit Sulawesi was not the first one to strike Indonesia, nor will it be the last. The country is located on the Ring of Fire, a belt of seismic activity that encircles the Pacific Ocean and is prone to frequent earthquakes and volcanic eruptions. In 2004, a massive 9.1 magnitude earthquake off the coast of Sumatra triggered a tsunami that killed more than 200,000 people in 14 countries, including Indonesia. In 2018, another tsunami caused by a volcanic eruption killed more than 400 people in the Sunda Strait. While the geological intricacies of the Earth continue to unravel, one disturbing theory emerges as a potential catalyst for the impending European tsunami: volcanic activity. It's the restless giant of the Mediterranean, Mount Etna, that has raised eyebrows and stirred unease among scientists. Mount Etna is the highest active volcano in Europe, with a current height of 3,357 m, 11,014 feet. It is located on the east coast of Sicily, Italy, between the cities of Messina and Catania. It is one of the most active volcanoes in the world and has been erupting almost continuously for thousands of years. The eruptions of Mount Etna have produced various types of lava flows, ash clouds, pyroclastic flows, and lahars, which have shaped the landscape and affected the lives of the people living nearby. Mount Etna, however, has been displaying unusual behavior. Scientists have observed a slow but relentless shift of the volcano toward the Mediterranean Sea. Simultaneously, in 2022, the volcano erupted not once but twice, further fueling concerns about the potential disaster lurking beneath the surface. Mount Etna's tectonic and volcanic activity raises a key question. Could it be the source of the imminent tsunami? According to some experts, the answer is yes. They warn that the movement of the volcano could cause a massive landslide that would displace a large volume of water and generate a powerful tsunami wave. The wave would travel across the Mediterranean Sea and reach the shores of several European countries, such as Italy, Greece, Spain, France, and even the United Kingdom. The estimated height of the wave could range from 10 to 30 meters, depending on the location and the topography of the coast. The possibility of such a scenario is not unprecedented. In 2002, a large chunk of the volcano's flank collapsed into the sea, creating a small tsunami that damaged some boats and buildings along the coast. In 2018, a study by the Geomar Helmholtz Center for Ocean Research in Germany measured the advance of the volcano through underwater pressure sensors and concluded that one day, Mount Etna will collapse into the Ionian Sea, putting communities around the Mediterranean region at risk. According to Dr. Heidrun Kopp, a co-author of the study and a geophysicist at the Geomar Helmholtz Center, the collapse of Mount Etna would be a worst-case scenario, and that the risk of a tsunami should not be underestimated. In her words also, the monitoring of the volcano should be improved, and that the public should be aware of the potential hazards. What does this prediction mean for us, ordinary citizens residing in the potentially affected regions? The implications are staggering and far-reaching. If the prediction turns out to be true, The consequences could be catastrophic. Widespread flooding, substantial damage to infrastructure, loss of property, the displacement of thousands of people, and severe disruption of the regional economy are all within the realm of possibility. In other words, the Pacific Northwest, a region known for its natural beauty and thriving communities, could be facing an unprecedented crisis. Amidst the unsettling prediction, there's a glimmer of hope: preparedness. We cannot prevent natural disasters, but we can certainly take measures to mitigate their impact and safeguard our communities. For instance, we can develop emergency plans, stock up on essential supplies, reinforce our buildings, and stay informed of the latest updates. Meanwhile, a recent report showed that disaster early warning systems are doomed to fail. According to the report, these systems often fail to reach the most vulnerable populations, lack adequate funding and coordination, and face technical and social challenges. These challenges include the difficulty of predicting complex and uncertain events, the lack of reliable communication channels and public trust, and the insufficient capacity and resources of local authorities and communities to act on the warnings. Disasters associated with natural hazards are constantly in the headlines. Some involve predictable human-made factors, such as the catastrophic floods in Derna, Libya in September, which were caused by the collapse of 2 dams after torrential rains. Others are unexpected, such as the eruption of volcano Hungatonga Hunga Ha'apai in Tonga in January 2022, with a plume that reached a height of 57 kilometers. That eruption caused a Pacific-wide tsunami and cut the country's undersea communication cables, shutting down national and international telephone and internet traffic. In all cases, what causes natural hazards and disasters is their damaging effects on communities and ecosystems. These can often be avoided, or at least mitigated through accurate forecasting of an event, advance warning to the relevant populations, and well-prepared response plans. However, these elements are not always in place or effective, especially in low- and middle-income countries, where the risk of disaster is highest and the resources are scarce. In March 2022, the United Nations Secretary-General Antonio Guterres announced an early warnings for all initiative backed by a $3.1 billion investment over 5 years. The aim, he stated, is to ensure everyone on Earth is protected from hazardous weather, water, or climate events through life-saving early warning systems by the end of 2027. This commitment is necessary, bold, and ambitious. Here we argue that it is also doomed to fail unless it is supported and implemented from well beyond the realms of the UN. Natural hazards cannot be forecasted, warned about, or responded to in isolation. This is because they depend on hydrological, geological, and atmospheric conditions and are often interrelated. An earthquake can trigger a tsunami. Heavy rains can lead to landslides or floods. The UN has had a key role in developing early warning systems, both through focused efforts, such as in meteorology through the World Meteorological Organization, WMO, and through broader initiatives, such as a multi-hazard management plan called the Sendai Framework for Disaster Risk Reduction 2015-2030. Despite much progress, the UN and its member states are not on track to meet the 2030 goals of the Sendai Framework. Notably, significant gaps exist in multi-hazard early warning systems. These gaps stem from the fact that the UN is a disparate collection of bodies that have a range of mandates, some more organized than others. For example, the WMO and its member states have successfully developed and coordinated early warning systems for hydrometeorological hazards, such as tropical cyclones, floods, heat waves, and thunderstorms, as well as systems to share relevant observations and associated forecasts between countries. Tsunami warnings are coordinated by the Intergovernmental Oceanographic Commission of the UN Cultural Organization, UNESCO, together with the WMO. The UN Office for Outer Space Affairs promotes efforts to address the threat posed by near-Earth objects, working with the International Asteroid Warning Network, which was established in 2013. No UN organization coordinates volcanic warnings, however, with the exception of aviation advice on volcanic ash, for which the International Civil Aviation Organization takes the lead. Currently, only about 35% of Earth's historically active volcanoes are continuously monitored. Similarly, there is little coordination of warning systems for landslides, earthquakes, or severe geomagnetic storms, all of which pose catastrophic risks, or for emerging risks, such as wildfire-generated thunderstorms. This organizational patchwork, combined with differences between countries and regions, hinders the smooth running of early warning systems across the world. As a result, many people remain exposed and vulnerable to natural hazards, especially in remote and marginalized areas, where the access to information and services is limited. Thanks for watching. For a more thrilling and informative video, click now on the next video that pops up on your screen.